Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Maths. And without any further ado, let's look at these questions that we have here. Okay, so we have question 5. It says the diagram below shows the graph of f of x is equals to a over x plus p plus q. The asymptotes of f intersect at -3 is to -1 as the coordinate, and then f cuts the x-axis at x is equals to -5. So as we can see right there. Then 5.1 says write down the values of P and Q, and that is only for 2 marks. So that means we can visibly see the values for P and Q. So we know that P should represent the vertical asymptote here, since it will cut the x-axis, and then Q should represent the horizontal asymptote, since it should cut the y-axis, right? So how are we supposed to find that one? So P should be in here, and then Q should be there, right? But then according to this, we are given x plus p, and then looking at this coordinate here, -3 is to -1. This represents our asymptote as we are being told here. The asymptotes of f intersect at -3 is to -1. So we have our vertical asymptote here being represented by the x coordinate, it's -3. But then according to this, we understand that here it is a plus, so we must write our p as a positive. So we must say p is equals to +3, right? So that when we have this x plus 3, then we are able to find our horizontal asymptote as x is equals to -3, right? So which is why we should write our p as a positive here, right? And then to write our horizontal asymptote, we know that for the horizontal asymptote, you just simply write it the way it appears here. So obviously here, this will be represented by our y coordinate, which is -1. So that means Q should be equals to -1. And then for 2 marks, that's how you were supposed to write the values of P and Q. So note very carefully how you should write the value of P. So you should always check what sign does it have here, and then it must always have an opposite sign here. So if it is negative, then here it must be positive. If it was positive, then here it was supposed to be negative, right? So I hope I make sense there. Now, this is 5.1. Let's go to 5.2. It says determine the value of A. Right. Now, for the value of A, we will realize that here we do have coordinates for this one, which can be written as -5 is to 0, since this here represents the x-intercept, and then we know for the x-intercept, the y-coordinate should always be 0. So having our equation, f of x is equals to a, and then x, remember we already have the value of p, so we can just go +3 here, and then we also have the value of q, so it's -1. Now at this point, we can use this coordinates here of the x-intercept in order to calculate the value of a by simply substituting those coordinates. So f of x is for the value of y, so we're going to put 0 there, and then we have a, and then x here is for the value of x, so -5, and then +3, and then -1, right? At this point, we do understand that we need to take this -1 over to the side, so it becomes +1, and then we have a over -5 plus 3. This will give us -2, and then if we cross multiply here, that means our a will be equals to -2, right? So that's how you were supposed to find the value of A there. And then for 5.3, they say now, hence or otherwise, calculate the y-intercept of f, right? Now, to calculate the y-intercept, we already know for the y-intercept, that's where you make x 0. And to say, so for the y-intercept, you make x 0. So remember, we already have the value of A, P, and Q. That's why they're saying hence, right? So from whatever that you have calculated above, you need to use that in order to find the y-intercept. So remember, our A is -2, and then we have x. Our p here was a positive 3, and then we had a minus 1. So at this point, we understand that y-intercept, you make x 0. So that means all we are supposed to do is say y is equals to negative 2, and then in the position of x, we replace with 0, and then plus 3 minus 1. At this point, you only just need to grab your calculator and punch all of that into your calculator. So this will give us negative 5 over 3, right? So just like that, you have calculated the y-intercept of f, right? Then let me indicate this was for 5.3. Now let me calculate 5.4. It says write down the domain of f. So we know domain. What is the definition of domain? This is a set of all possible x values, a set of all possible x values. So remember, looking at a hyperbola, you know that all x values can be valid in this graph here, but then we only have to exclude the asymptote. So we are going to say x element of real numbers, but where x is not equal to the asymptote, which the asymptote is negative 3. So x is an element of real numbers, but where x should not be negative 3, because negative 3 is an asymptote. So that means asymptotally akuna value lapho, right? And then determine the line of symmetry of f with a negative gradient in the form y is equals to mx plus c. Now, I've spoken so many times about this one, and then I hinted to the bus method, whereby if you have your f of x is equals to, remember we had a negative 2, x plus 3, then a minus 1. So if you want to determine the line of symmetry or the axis of symmetry with the bus method, this is what you do. So you only consider this here. So you ignore the value of a and only take this one here. Right. So obviously you're going to write your f of x as y, but then since they're looking for the one with the negative gradient, you have to remember to put the denominator inside the brackets and have your negative outside here, because they're looking for the line of symmetry or the axis of symmetry line or equation with a negative gradient, right? So that means what I'm going to write here is say y is equals to negative in bracket x plus 3 and then minus 1, right? So this indicates that I'm looking for the axis of symmetry with a negative gradient. So this is y is equals to negative x and then a minus 3 here and then minus 1. So y is equals to negative x minus 4. And there you go. This is the equation of the axis of symmetry or the equation of the line of symmetry with the negative gradient. So that's how you were supposed to do it. Now, mind you, if they had said with a positive gradient, then I would simply just write all of this the way it is. So if they were saying the one with the positive gradient, then I wouldn't have put a negative here. I would just say y is equals to x plus 3 minus 1. And then this would become x. 3 minus 1 is 2. So this would be the one with the positive gradient. Note what I do for the one with the negative gradient. Simply just put the denominator here inside the bracket and have the negative just before the bracket. I hope that makes sense. Right. And then let's now check 5.6. It says for which values of x is f of x greater or equal to 0. Now, the way you make sure that you find the correct answers to this kind of questions, it's by interpreting this correctly. Now, f of x greater or equal to 0 simply means look for where the graph of f will be above the x-axis. So look for where the graph of f of x will be above the x-axis, right? So where do you see the graph being above the x-axis? So you will soon realize that it is above the x-axis right at this point here, right? So at this point, we can see that the graph is above the x-axis, right? Now looking at this point here, if you were to look at any other points just for confirmation, you would realize that anywhere else besides that point, we see our graph of f of x is below. Remember, the x-axis is this horizontal line here. that passes through the origin. So we can see the graph here being below the x-axis, and also for this part here, we can see it's below the x-axis. But then for this one, we are looking for where it is above because it is greater than, but then greater than and also equal to, meaning it's above the x-axis, and at the same time, it must also include the value where it is exactly at the x-axis. So the point must be exactly at the x-axis, meaning that we can also include the critical value. So the critical value is what here? It's the -5. So the -5 should also be included because -5 is directly at the x-axis. So how are we going to write this? So since it's between this point, we need to know the value for this point here. Right, because after here, we can see the graph is going back down below the x-axis. So now the question is, what is this coordinate here? And then looking at this one, remember they said the asymptotes of f intersect at -3 to -1, and this is where they intersect. So that means this was -3 because this represents the x-coordinate. So this line here is cutting through the x-axis, so it must be represented by the x-coordinate. So that means, in other words, where we see the graph of f being above the x-axis, it's between -5 and -3. But now the challenge is, how do we write that? So this is how we are going to write that. We're going to say for x element of -5. Now, note that I'm using round bracket for -5 because -5 is also an inclusive value. Since at -5, we can see the graph is not above the x-axis, it's not below the x-axis, but it is exactly at the x-axis, which also this one is an option. So -5 is 2, -3, but then I'm going to use round brackets. Why? Because at -3 we cannot include that critical value because -3 is an asymptote. This is where the graph doesn't touch, right? So it cannot be an inclusive value because -3 is invalid. So if you were to substitute -3 as your x value to the equation, it will give you maths error. Now this is one way of writing it. Others might choose to write it in this format, to say x, put x here in the middle, and then this will read where x is greater or equal to -5, but x is less than -3. Now this means the same thing. It's just a matter of which one do you prefer, right? You can either write it that way or you can write it that way, right? So nice. For 2 marks, that's all you were supposed to do. Now, let's check 5.7. It says, describe the transformation. Describe the transformation of f to g, given that g of x is equal to 2 over x minus 1 plus 1, right? So this is what we are going to do. First of all, let's write the equation of f of x originally as it was, -2 over x plus 3, and then we had plus minus 1. Okay, nice. Then this changed to that, right? So now we want to understand how did we get to this part. Now understand that our a here was negative, but now our a is positive. Whenever our a was negative and now it is positive, we know that that represents a reflection along the x-axis. So if we can just revise for a bit, if we have f of x and then this changes to negative g of x, this is a reflection along the x-axis, right? Because it affects the whole y coordinate. Now if we have f of x and then it changes to g, but then negative x, only the x becomes negative, then this is a reflection along the y-axis. So in other words, a reflection along the x-axis affects the whole equation because it affects the whole y coordinate, and then a reflection along the y-axis only affects the x coordinate, right? So at this point, how did this change to that? Our g of x is 2 over x. So if we were to change this would be 2 over x plus 3, and then here would have plus 1, right? But then again, they did something here from the positive 3. So let's say this is not g of x right now, it's h of x, right? Now to get to g of x, there's something that they did to this 3 here. So this is 2 over. Now they wanted to get to negative 1. So this is x plus 3. They had to subtract what? 4. And then plus 1. So this became 2 over x, and then minus 1, and then plus 1. Now the question is, what was done here by saying minus 4? What is this? This is a translation, right? But then we do understand that translation, when it comes to this, if we have x plus p, this is a translation, p units to the left. So remember, with a horizontal translation, if we have a positive, it is to the left. But x minus p, this is a translation, p units to the right. Now, what am I trying to say here, or what am I trying to point out? Whenever we have a plus a certain value, then that is a translation, p units, or that certain value to the left. So that's plus. Plus indicates to the left. So don't get it confused. This only works in horizontal shift. So if we have positive, it is to the left. If we have negative, it is to the right. So here from positive 3 to negative 1, we had to subtract negative 4. But then obviously this now indicates x minus p. This is now a translation, p units to the right. But then what is the p here? It is indicated by the minus 4. So this is a translation, negative 4 units, or 4 units to the right. Right, 4 units to the right. This is a translation, 4 units to the right. So all in all, how are we supposed to describe this transformation that took place here? Number one, we want to comment on this translation here, or this transformation. So this was a reflection along the what? The x-axis, because the a was negative, now it's positive. We've came to understand that if we have something like this here, then it simply means that this is a reflection along the x-axis. So it can also be in the form whereby we have negative g of x going back to positive f of x, right? So that represents a reflection along the x-axis. It was negative here, now it's positive. But then if the x was positive and now the x is negative, that is a reflection along the y-axis. So note that. So how are we going to describe this transformation? So number one, we are going to say this is a reflection along the x-axis and a translation 4 units to the right. So understand that it is a reflection along the x-axis and a translation 4 units to the right. 4 units to the right because we had to say minus 4. So if we say minus 4, it is to the right. If we had said plus 4, it would be to the left, right? So I hope all of that makes sense. Okay. Let's now proceed to the next question. Okay, so now we are on this question 6 here. It says, given f of x is equals to 3 over x plus 2 minus 1, calculate the value of k if k is to 2 is a point on f. So we do understand that we are given in coordinate form. This represents our x value and the 2 represents our y value. So we want to find the value of k by simply substituting in this equation here, by simply saying where there is f of x, which is, we understand this is y, let's put 2 there. And then where there is x, we're now going to replace by k. So this is k plus 2, then minus 1. Now at this point, you need to be very careful. A lot of you make this mistake of first cross multiplying here, but then the first thing that you should do is take this negative 1 here and transpose it over to the other side. So always, when solving this type of questions, understand that the first step is always to take the constant here and transpose it over to the other side, and then you can cross multiply. So we have 2. The negative 1 will jump over to that side. It becomes positive 1. So what is 2 plus 1? It's 3. And then this is 3 over k plus 2. Now at this point, you can then cross multiply because there is no constant right now. So what is 3 times k? That's 3k. And then 3 times 2, that's 6. And then is equals to 3. At this point, again, you need to take this 6 over to the right-hand side. So this becomes 3k. 3 minus 6 is negative 3, and then we can divide both sides by 3 because we are looking for k. So our k is equals to negative 1. And just like that, your 2 marks in the bag. Okay, so let me indicate this was 6.1. Okay, now let's move to 6.2. So 6.2, it's saying write down the equation of the horizontal and vertical asymptote. Right. Now, the horizontal asymptote, we know that it is indicated by that constant there. So the horizontal asymptote would be y is equals to negative 1. So as simple as that, you simply just look at your constant value here together with its sign and then equate it to y. But then for the vertical asymptote, you need to understand that you need to take the denominator here and then equate it to 0 and then solve for x. So your x is going to be negative 2. So that means this represents your vertical asymptote. Right, so the vertical asymptote is x is equals to negative 2, and your horizontal asymptote is y is equals to negative 1. Do not be confused. The horizontal asymptote cuts through the y-axis, which is why it is the equation y is equals to. But the vertical asymptote cuts through the x-axis, which is why it has x is equals to negative 2. Okay, then we have 6.3. It says calculate the coordinates of the y-intercept. Note this one, the coordinates, right? They're not only saying calculate the y-intercept. So I'll show you the difference why I'm saying that. So if you want the y-intercept, you should remember to make your x 0, right? So every time you're looking for the y-intercept, make x 0. And then this is what we have now. So this is y is equals to 3, then where there is x, I put 0 plus 2 minus 1. So this is y. If we punch all that into our calculator, the value that we are going to get there is 1 over 2. So we have 1 over 2 in coordinate form. This should be written as 0 is to 1 over 2. So we always know that when you write something in coordinate, it should always be x is to y. Right, so this is our answer in coordinate form. So it's different from what we have here. So if you can just take a look at this previous question that we did here, this one was simply saying, hence or otherwise, calculate the y-intercept. So which is why we did not have to write it in coordinates. If you did write it in coordinates, it's okay, but then it was not necessary because they did not say the coordinates. But once they say the coordinates, you must always present your solution in terms of the coordinates. Then we have 6.4. It says calculate the coordinates again of the x-intercept. So for the x-intercept, always remember to make your y 0. So in this case, our f of x, we do understand it is similar to y. So that means this is where we put 0 there. So this is 0 is equals to 3 over x plus 2 and then minus 1. Again, you don't start by cross multiplying. You start by transposing the constant. So the negative 1 jumps over to the left-hand side. It becomes positive 1. And then this is 3 over x plus 2. Right. X plus 2. Then obviously when this here cross multiplies with that one, it still becomes x. And then obviously now our x coordinate, if we say 3 minus 2, this is equal to 1. So that means in coordinate form, this will become 1 is to 0. Right. So this becomes 1 is to 0. Okay, now we are fine with that one. So 6.5 says sketch the graph of f, clearly showing the asymptote and the intercept with the axis. So with this one, it's a sketch. So let's try to sketch. So obviously starting with our Cartesian plane, this is what we have. And then let's indicate a different color for the asymptotes. So we have our asymptote at, we said at -2. So that's the vertical asymptote there. And then we also have another one at -1. So which is the horizontal asymptote. So let me put it closer there. So at this point, we understand this is our origin. And then we need to indicate our intercepts with the axis. Remember, we had 0:2, 1/2, and then also 1:0, right? So let's indicate now. The 0:1 1/2 could be somewhere here. And then the 1:0, let's say it's somewhere there. So let's note that this here is -1. And then what we have, so this is what we have as our vertical asymptote here. This is it's crossing over. Okay, so this one is -2, and then this here is -1, right? Pardon me for that. And then that means our graph will join smoothly like that. And then there goes our asymptote. There goes our asymptote that it never touches. And then here, between those asymptotes, should just have another wing here to indicate that this is a hyperbola function. So it must always be represented by 2 of these wings. And then we can just extend it like that. Right. So at the end of the day, you should have something like this. So here we have 0:1 over 2. And then here we have 1:0, right? And then we can then label this F, right? At the end of the day, this is the equation that you should have. So this is the graph that you should have. So all the intercepts have been shown clearly, intercept with the axis. All the asymptotes have also been shown clearly with the blue there. So nice, nice, nice. Awesome. Let me just make this one black. Right. Okay, so now we are through with that one. Let's now move to, they say, one of the axes of symmetry of F has a negative gradient. Determine the equation of this axis of symmetry. So I don't want to erase this as yet. But then remember, from the previous question, I did say that we should use the bus method. If they're looking for the one with the negative gradient, then this is how we should determine that. So take this here, and then remember to put the ones in the denominator inside the bracket, and then have a negative here. So this is supposed to be y is equals to negative in bracket x plus 2 and then minus 1. So this is y is equals to negative x minus 2 minus 1. So your y is equals to negative x minus 3. So just like that, this becomes your equation of the axis of symmetry with a negative gradient. Right, and then now for 6.7, they're saying determine the values of x for which 3 over x plus 2 minus 1 is greater than negative x minus 3. Now, if you were to check here, you would see that the 3 over x plus 2 minus 1 is actually the graph of f of x, right? So in other words, this is where f of x is above the axis of symmetry, right? So let's say the axis of symmetry is g of x for argument's sake. Then this is negative x minus 3, right? So this would actually mean, where is the graph of f above the graph of g, right? So if we are to take the axis of symmetry with the negative gradient as our equation of g of x, this here, when we interpret it, it would mean, where is the hyperbola graph above the axis of symmetry with the negative gradient? Now, understand this. The axis of symmetry with the negative gradient would have to pass through here. So if we were to draw the axis of symmetry with the negative gradient, it must pass through the asymptotes here, through the midpoint of the asymptote, going that direction because it's a negative gradient. Now, in other words, we are looking for where the graph of f, meaning the hyperbola function, is above the graph of g, which is your axis of symmetry. Now, looking at this point here, just before negative 2, so if we are to indicate like this, you would see that in that segment, which graph is above the other, we can see that the graph of g of x, is above the graph of f, right? So we can all see that. So the straight line graph is above the hyperbola graph. So that's before negative 2. But then now let's check. After that point, there is something else we need to note, right? Now, after that point, we have this here. What is it that we note there? We can see that the graph of f is above the graph of g, right? The hyperbola function is above the straight line function. So that means this only starts to exist when x is greater than negative 2. So for all the points where x is greater than negative 2, the negative 2 being the asymptote, so it cannot be included as a critical value. So it's for all the values where x is greater than negative 2. So all the values going from to the right of negative 2 all the way till infinite, we will always observe that the graph of f will be above the graph of g. So that means our solution for that one here is simply when x is greater than negative 2. So this is where we see the graph of f being above the axis of symmetry with the negative gradient. Okay, so I hope that makes sense. Okay, and then now I can erase all of that. So I only wanted to show you that point. 6.8, it's saying the graph of f is transformed by a reflection over the x-axis followed by a translation 4 units in the positive direction. Let's note that in the positive direction. What does that mean, right? In the positive direction simply means to the right. To the right is the positive direction. To the left is the negative direction, right? So the graph of f is transformed by a reflection over the x-axis. Now you will remember in the previous question, I did state that if you have your f of x changing to negative g of x, this represents a what? A reflection along the x-axis, right? But then if you have your f of x changing to g negative x, this represents a reflection along the y-axis, right? And then I did say if you have x plus p, this represents a translation p units to the left. And then if you have x minus p, this represents a translation p units to the right. So always have that in mind. Always have that in mind. If it's plus p, it's to the left. If it's minus p, then it's to the right. And then also note your reflections, Right. Now, at this point, we do understand we are being told that this is transformed by reflection over the x-axis. So what are we supposed to do now? Let's reflect this over the x-axis. So originally, we have our f of x is 3 over x plus 2 minus 1. But we do understand that our f of x must change to negative g of x. So this is supposed to be a negative. So as our g of x, we must have negative and then all of this, right? 3 over x plus 2 and then minus 1, right? So this is what it means, right? So I must put that inside the bracket and then have a negative just before there. So this will become negative 3. Note that this negative here only affects the a value there. So the sign does not change with the denominator here. And then also it affects this constant here. So negative and negative, it becomes positive 1. Right. So this has been reflected along the x-axis. But then we are not done. That's not the only transformation that took place. Also, it is followed by a translation 4 units in the positive direction. So that means I must still continue and say negative 3 over x plus 2. And then since they said in the positive direction, I need to say minus 4. Because I understand if it is to the right, then it's minus p. It's x minus p. That is to the right. X plus p represents to the left. So this is left, this is right. This is positive direction, and then this is negative direction. Okay, so I have plus 1 here, and then this is supposed to be negative 3 over, so 2 minus 4, this is going to give us a minus 2, so x negative 2, and then plus 1, right? So this becomes our equation for g of x, right? So that's how you were supposed to determine this equation in its simplest form. So in its simplest form, it's g of x is equal to negative 3 over x minus 2 plus 1, right? So even if you chose any other letter like h of x, or you just simply chose to write y, it's correct because they did not tell you that the graph of f is being changed to graph of g or anything else. Okay, so and that's how you could have grabbed all those marks. And now let's move to the next question. Okay, so now let's look at question 6. It says the diagram below shows the graphs of f of x is equals to a over x plus p plus q, and g of x is equals to bx plus c. The asymptotes of f are at x is equals to negative 3 and y is equals to 1. F and g intersect at a. The x-intercept of f and b, while c is negative 2 is to 6, is a point that lies on f. G passes through the point d, which is negative 3 is to 1, the point of intersection of the asymptote of f. So d is a point of intersection of the asymptote, as we can see here. But then b here is a point of intersection of the two graphs, f and g, right? 6.1 says write down the equation of f in terms of a, right? So in terms of a, this is what we are supposed to do. We understand that our p, we are already given the vertical asymptote as x is equal to negative 3, but then we know that the p should be indicated as a positive. So p is equals to 3, and then q, we are already given the horizontal asymptote as y is equals to 1. So our q should be equals to positive 1. Now, if we are to write the equation, this will become f of x is equals to a over x plus 3 and then plus 1. And then we should leave it like that. Remember, they said in terms of a. So that means at this point, we are not required to find the value of a. We are just supposed to write it like that. Okay, so now 6.2, that's when they're asking us to determine the value of a. So for 6.2 now, we are going to use the set of coordinates here, if we can check, we are given the coordinates of C, so which are -2:6, which we can use to find our value of A there. So where there is f of x, we understand that we should substitute our y coordinate, so that's 6, and then A over where there is x, let's substitute our x coordinate, -2, and then we have +3, +1. Now, again, the first thing that you should do, take this one here and transpose it over to the left-hand side. So 6 minus 1 becomes 5. And then here we have A, -2 plus 3 is a +1. And if we can just cross multiply 5 times 1, this A is equals to 5, right? So that's all you were supposed to do there to bag that 2 marks, right? And then now 6.3 is saying determine the coordinates of the x-intercept of f. Note that the coordinate. So that means for the x-intercept, we must remember to make y 0. And then let's write our equation now that we have the value of A. That's 5 over x plus 3 and then plus 1. And then remember, we make y 0. So we're just going to put 0 here. And then this is 5 over x plus 3 and then plus 1. Again, the first thing that you should do, take the 1, transpose it over to the left-hand side. And then you have 5 over x plus 3. Then at this point, you can cross multiply this. So it becomes -x minus 3 is equals to 5. And then you can transpose the -3 over to that side. It becomes +8. And then if you are to divide both sides by -1, then your x will be equals to -8, right? But then remember, you're supposed to write this in coordinate form. So that means remember, if we are to check here, the coordinates of the x-intercept are actually being represented by coordinate A there, or point A, because this is the x-intercept. So we can then say A, therefore A is -8 is to 0, right? Okay, nice. Now 6.4 says determine the values of B and C and write down the equation of G, right? So we are being told that this line here, ADB, or this line here, including the points ADB, is actually the line G, right? So how can we determine the equation there? Now, note that we are given the coordinates of D because we are being told, also here, looking at this one, the coordinates of D are -3 is to 1. And then we just recently calculated the coordinates of A, which were -8 is to 0. Now, looking at this here, G of X is equals to bx plus c. We can tell that this is written in the form of mx plus c, where our b here is actually indicating the gradient of the equation, right? So by calculating the gradient of this straight line, we have found the value of b, right? Or we would have found the value of b. So that means let's calculate the gradient of AD since we have the coordinates A and the coordinates of D. So this would be y2 minus y1 over x2 minus x1. So this would go as, let's say, 1 minus 0 over -3 minus -8. Now, if you punch that into your calculator, you get 1 over 5, right? Positive 1 over 5. So note that this is the gradient, but then we did say that the gradient represents the value of b. So we can say, therefore, b is equals to 1 over 5. Now we want to find the value of c. So it should be pretty simple given that this is a straight line here. We can simply just use one of these coordinates here. So let's say we use the coordinate of a because it looks way simple. But then you can also use the coordinates of D. We know that in terms of that, you can either use any coordinates that you wish, either the coordinates of A or the coordinates of D. So I'm choosing the coordinates of A because they look much simple and then they have 0 there. So I will just say G of X is now equals to 1 over 5 X plus C, right? And then I'm going to substitute the coordinates of A. So this is 0. is equals to 1 over 5. And then where there's x, I'm going to put the x coordinate, which is negative 8, and then plus c. Now, to calculate that, we do understand c is equals to, this would give us negative 8 over 5, but if we transpose it, it becomes positive 8 over 5. So in other words, writing this now as an equation of g, it is supposed to be, so it is 1 over 5 x plus 8 over 5. Right. And that's how you are supposed to write that. Okay, now let's proceed. We have write down the domain of f, right? So we have already spoken about the domain. We say the domain is a set of all possible x values. So that means here, we're just going to check the set of possible x values. And then we already know the domain for a hyperbola graph is always x element of real numbers, where x should not be the asymptote, right? The vertical asymptote. Now, what is our vertical asymptote? It's negative 3. So where x is not equals to negative 3. So all the x values are valid, but then where x should not be equals to negative 3, because negative 3 is the asymptote. So if you were to substitute negative 3 as your x value there, you would find maths error. Okay, then 6.6 saying determine the coordinates of B, and then that is for 4 marks. Now, looking at B, we did state that B here is a point of intersection between the graph of F and the graph of G. And then you should always note this. Whenever you are looking for the coordinates of the point of intersection, you should always put this in the back of your mind. You need to equate the equations of the two graphs, right? So whenever you're looking for the point of intersection, you need to take the two equations of these two graphs and then equate them. So in other words, to look for the coordinates of B, I need to say f of x is equals to g of x. Then I will go ahead and write the equation of f of x. So remember, I already have the value of a, p, and q. So this is x plus 3 and then plus 1. Is equals to g of x. I already have the values of b and c, which is 1 over 5 x plus 8 over 5, right? Now at this point, you need to be very smart. You can play along with this one here to say, since I can see that all the rest here have a denominator of 5, how about we write this one here in terms of a denominator of 5? So we know this is just a quick manipulation. I can write 1 as 5 over 5. Now, I did not change anything. 5 over 5 is still equal to 1. But all I just did is manipulated this so that it has the same denominator as the rest of the terms on the equation, right? Now, at this point, we can now see that since we have 5, 5, 5, and then this x plus 3, then that means our lowest common multiple should be equals to x plus 3 and then times 5, or let's just write it as 5. So our LCM should be 5 bracket x plus 3, right? So this is it. So this will be our LCM, right? Now, if this is our LCM, we do understand what needs to be done. So remember, in the denominator, we divide first, and then when we go to the numerator, we have to multiply. So if we were to take the LCM divided by the denominator here, we do understand that the x plus 3 and the x plus 3 will cancel out. So we are left with the 5. The 5 must multiply with the 5 there, which is becoming 25. And then this here, if we take this here and divide by that 5 here, we do understand that the 5 and the 5 will divide out, but then we'll be left with the x plus 3. So the x plus 3 must multiply with the numerator here. So this becomes x plus 3, right? And then at this point again, we have our LCM. So if we were to divide it with this one, 5 x plus 3 divided by 5, the 5 and the 5 would cancel out, and then we'll be left with x plus 3. But then the x plus 3 would multiply with the 1x here. Remember, the x here belongs to the numerator. So this would be x bracket x plus 3. And then also again, the same thing happens here. If we say 5 bracket x plus 3 divided by 5, the 5 and the 5 cancels out. We are left with the x plus 3, and then which should multiply with the numerator 8. So 8 bracket x plus 3, right? So that is just a math from your grade 8 and 9, but then you also need to really note it there, because that's where a lot of people would be making mistakes. Then, okay, now we have 25. And then if we multiply inside here, this is 5x plus 15. And then this is equals to x squared plus 3x, and then plus 8x plus 24. Now at this point, we do understand that we must collect our like terms. So let's just write this as x squared. And then what is 3x plus 8x? That is becoming 11x. And then if we say 11x minus 5x, this will give us positive 6x, right? And then if we are to say what is 25 plus 15, that will give us 40. And then if we say 40 or 24, so remember the 40, we must transpose it over to that side. If we say 24 minus 40, that is supposed to give us minus 16, right? So minus 16. So you can do the maths to confirm that is equals to 0. Now at this point, we do understand that this is the part where we need to actually factorize. So this will become, it's like that. And then this is x distributes in both brackets. And then now looking for the factors of 16. When you multiply them, they're going to give you 16. When you subtract them, they're going to give you 6. It's obviously 8 and 2. So we're going to have 8 here and then have 2 there. Right, now we always know that the sign of the middle term must go to the bigger number. So that's positive here and then negative here, right? So if we say 8 multiplied by negative 2, that's negative 16. But if we say 8 minus 2, that's positive 6, right? So just like that, we have factorized correctly. Then x is either equal to negative 8 or x is equals to 2. But then if we can check, the negative 8 here has already been given to a. Also note that a there is a point of intersection between the graph of f and g. So where a is, that's where those two graphs meet, the graph of f and g. But then the negative 8, as we can see here, it is for a because we did calculate previously. And then also confirming with our Cartesian plane, we know that this side here it should be negative, but then this side here it should be positive because now it has crossed the y-axis. Then once we have crossed the y-axis, our x values start to be positive. So it makes sense that the positive 2 needs to be here. But then remember, we are not only calculating the x coordinate of b, we are calculating the coordinates. So after finding the x coordinate, we should also go back and substitute to any of the equations, whether the equation of f or the equation of g, in order to find the y value. So it all depends on what you choose to substitute in. Let's say you substitute in the equation of f. So where there is x, you'll put positive 2, meant to say. So this is 5 over, so where there is x, it's 2 now. So 2 plus 3 and then plus 1. Now this is 2 plus 3 is 5. So 5 divided by 5 is 1. And then 1 plus 1 is 2. Right? So the coordinates of b would actually be 2 is to 2. Right? So that's how you would find the coordinates of b. Just like that. Nice. Okay, so 4 marks. Maybe it was a bit long, but then, yeah, that's how you were supposed to find it. Then 6.7 says determine the values of a for which x times f of x is greater or equal to 0. Now, also this question is whereby most of the learners fail because they cannot interpret this question and get to understand what it is actually looking for. So basically, this goes back to the fact that if you have a positive times a positive, it will always give you a value that is greater than 0, right? And then if you have a negative again a negative multiplied by negative, it will also give you something that is greater than 0, a value that is greater than 0. So in other words, you are looking for where the x values are positive, and as well as your f of x is positive, meaning it is above the x-axis. So you're looking for the quadrant or the segment where your x values are positive, but at the same time we can see that your graph of f will be above the x-axis. Or you are looking for where the coordinates will be negative, but then at the same time your graph will be below the x-axis. Right. So that's where the negative and negative and positive takes place. Right. Now, if you were to check here, between this point here, I want you to fixate your eyes here. Right. So right at this point here. Now, remember, the x coordinate at A is -8. Right. Now, we do agree that at this point here, because this is to the left of the origin or to the left of the y-axis, we do agree that at this point here, we can see that we have negative x values. As you can see, -3, -8. We have negative x values. So our x values here are negative. But then at the same time, what is happening to our y values? Our y values are also negative because we can see this graph of f of x here is actually below the x-axis. So our y is also negative. Now, if we say negative x multiplied by negative y, we do agree that this would be positive xy, right? That's what we are looking for here. We are looking for where the x values are negative and also the f of x is below the x-axis, meaning that it is negative. So this is the first condition that is being met. And then it is being met between which point? Between where x is actually, let's indicate like this. So where x is greater or equal to -8, but where x is actually less than -3. Now, why don't I say x is less than or equal to -3? It's because -3 is an asymptote, so it cannot form part of the critical values, because at -3, the x value does not exist. Where we put x as -3, this whole equation gives us maths error. So I need to be very careful not to say equal here. So where x is greater or equal to -8, but then it is less than -3. So this is the first point where we see that happening. But then we also have the second condition. We can look for where we have positive x values, and then we also have our graph of f being above the x-axis, right? So also, when we check at this point, so if we check at this point, we can see that our x values here, they are still negative because we haven't crossed 0. But then look at our f of x, it is above. So here it's negative and that one is positive. It does not suffice. So this is positive, but then your x values remains negative. So this one is not the one that we are looking for. But then check here. Just after this point, just after the origin 0 there, what is it that we see? Nice one. Right. So we can see that our x values are becoming positive. But then what is happening also to our f of x? It is positive because it is above the x-axis. So now again, we have positive times positive is greater than 0. Right. So which is what we have there. So we are supposed to say when x is greater, so condition number 2, when x is greater or equal to 0. So why am I including the 0 as a critical value? Because at that point, remember, this means it has to be the point whereby they are both positive or they are both at 0 there, right? So even if we have 0 as a point, that can also be included, right? So also that point. So it must be greater or equal to 0. Greater or equal to 0. It can be greater than 0 or at the point 0. So which is why we are saying where x is greater or equal to 0, right? So that's how we get that, right? So if you were to take the coordinate in here, multiply by that, you'll get 0, because this one here represents where y is equals to 0. Okay, so that's how you were supposed to find this. So remember these conditions. Whenever you are given something like this, you need to always remember these conditions. When you take a positive and a positive, it gives you a positive value. When you take a negative and a negative, multiply them, then it also gives you a positive value. And that's how you were supposed to tackle that question. And then I think we have reached the end of our marathon with the hyperbola questions. So I'm still going to post more on request. But then I hope you enjoy this lesson here. And then if you did enjoy it, you know what to do. Press the thumbs up button. And then also do not forget to share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.